Hello, everyone, and a very warm welcome to all of you for joining us today on this month's Serverless Saturdays. This is Rishit, and I have.
Dharmendra, yeah. Hello everyone. Welcome back to the another session of Solar Saturday, and let's
Yeah,
start
so
with
this
it.
one is going to be really interesting for me. The main reason is one of the pain points that I personally feel, and I'm sure all of the serverless developers would feel, is debugging, especially the Lambda function, not locally, but on the deployed version, right? And that has always been a challenge. Either you go to the Lambda console and you probably make the changes, and then you test it, you provide the input, and then you go to CloudWatch, you get the logs. It is doable, but again, I feel like it's a bit of a hassle. I think that is where we have our first speaker, Marko. So, Dharmendra, would you like to introduce?
Yes. So we have. You can present him
Yep.
over here. Yeah. So we have Marco. Hello, Marco. So he's been working in the industry for more than I think 15 plus years, and he's well known for his serverless life blog, and he also contributed to the uh, yeah, open search and open source, sorry. And he recently built the Lambda Live Debugger, and which is popularly known for the debugging your application locally from any cloud provider, either it is AWS or any other. So you can debug it locally. So hello, Marco. How are you?
Hi, thank you for inviting me.
Thank you.
Thank you so
Thank you
much.
for joining us early morning. So
Yeah. So, over to you, Marco. The stage is yours.
Yeah, first a short introduction. I'm Marko. I'm working with serverless for 8 years. I'm certified AWS professional, community builder, write blog servers live. Have a few open source projects like Lambda Live Debugger, Serverless Spy, and some others. And that's about it. So the topic of today's presentation is to debunk the myth that serverless is hard to debug and hard to develop and time consuming to develop. In the first part of presentation, I will show my open source tool, Lambda Live Debugger. And on the second, I will show you some tips and tricks for CloudWatch. Although you're probably very familiar with CloudWatch, I'm sure I will show you some things new. So what's the issue with serverless solutions? Well, one is it's really hard to simulate locally. But when you deploy, so to really test the solution, you need to deploy to the AWS, but that's time consuming, and then you cannot debug. The other problem with server solutions is that code is split into multiple lambdas, and events, messages are flowing through all the system lambdas, and it's really hard to capture everything and figure out what's going on and what is failing. Well, I will try to debunk this myth with and address those issues. So let's start with Lambda Live Debugger. I created a really simple project that says hello world. That's it. So what I will try to do is run a debugger and inspect variables, step through code. First, I need to install it. That's it. Then I need to configure it. there is a wizard for that. I will speed up things and just confirm all the default settings. And run the debugger. Wait a little bit. And that's it. We are connected. Refresh the page. And here we are. I can inspect variables, step through code, and that's it. End of the presentation. That's all it took to configure a Lambda Live Debugger and start debugging. It was like a minute or something. Okay, let's go back and go through all the settings I did. Let's run the wizard again. First, you have to specify the framework. That's usually the system detects it. I'm using CDK, so I can also specify CDK context. I could use monorepo. So what I usually do is putting all the CDK code into CDK folder, but not in this project. I could enable observability mode. I will talk about this later. I could enable that Lambda Live Debugger ask me for all the changes before it makes them. I could specify a profile, a region, a role. I could debug all the functions or just pick one or filter by some name. Save the settings. I can configure JetBrains tools like WebStorm, and Visual Studio Code is already configured automatically, but by this wizard. Additional logging, and that's it. Let's check what this wizard changed in the project. It added VS Code configuration, so we can run the debugger with F5 button and save the settings. That's all. No other changes to the project at all. So let's run again. Important part of Lambda Live Debugger is also that if you change your code, you don't have to redeploy. So let's type hello world 2. Sorry. I didn't save. So yeah, and we have a new version, or again. That's it. I didn't have to deploy at all. So this really speed up my development cycle. Yeah, let's go how this magic works. So this is website of the tool. Lambda Live Debugger can be used with JavaScript or TypeScript. Sorry, no Python or similar language support. It supports any framework. CDK, Serverless Framework version 3, SAM, Terraform, OpenTofu, or even any other framework that you may create for some special purpose. And even for those, it's really easy to configure. Now, how it works? Well, here we have a Lambda running on the cloud, and Lambda Live Debugger attach a layer to the Lambda, intercept calls, send them through AWS IoT to your local machine. And along with the request, there goes also AM permissions. So code is executed with the same permissions as in the cloud, which is really important because any other local environment usually don't simulate AM permissions correctly. Then code is transpiled, compiled on your machine, run a debugger, and then response go back to the Lambda. So it looks like the real AWS system responded. But at the same time, when you change the code, you don't have to redeploy. You only have to redeploy when you do some infrastructure changes, like adding permissions, adding queues, and Lambdas. For everything else, for code changes, you don't have to redeploy. Lambda, there are several other tools that can run Lambda locally, like serverless framework offline plugin, SAM, and some others, or local stack. But those are local tools. It doesn't really simulate the real AWS environment close enough. But there are some tools that does exactly what Lambda Live Debugger does. Well, SST framework was the first one. And also a serverless framework, the new version supports the same solution. But all other frameworks, which I would argue are more popular, doesn't support that. Here, the Lambda Live debuggers come in. And it has benefit to other two solutions. As I mentioned, you can debug just all the functions, or just few, or just one, which is really important for large projects. You may not want to run like 70 Lambdas at once because that's like resource intensive, and you want to look just one logs, one Lambda, or a few of them, and this is really useful. Another benefit is it's really quick to turn on debugging and off. For other solutions, you need to redeploy the whole solution, which is really time consuming if you want to turn off debugging and turn on. And there's another benefit, observability mode. Normally, you would, when you develop serverless application, you have your own private environment for that project. You should not deploy on some, well, eventually you do deploy on some dev, test, staging, and then production. But for your development, you should have your own environment on AWS. But sometimes that's impossible. And that's where observability mode comes in. Let's go to diagram how the debugger works. When you turn on the observability mode, Lambda still send the message via IoT to your computer, and here you debug, but the response don't go back. Lambda responds with the code that is currently deployed. So you can get all the real events for debugging, but you also don't disturb a real system. This way you can even debug a production system if you want. And that can be really useful for some special scenarios. Let's check how this works. So I will change the config. Restart the debugger. So let's run. So what you notice is that you get an old response from the code that is deployed on the cloud. I need to set the breakpoint. Yeah, so I can debug, although the solution is the Lambda is running and responding on the cloud as there were no debugger attached. Okay, let's go back. What I also need to mention. Yeah, when you stop debugging, well, there is still Lambda layer attached to the function, and it's sending messages to IoT. So when you finish your work shift or working on this project, it's great that you remove the debugger. That's especially important if you debug a production system with a lot of load, because the message still go to IoT and you will pay for that. But if it's your own personal project that doesn't do much on currently and doesn't receive events, then it's not a problem to leave it on. Okay, as I mentioned, Lambda Live Debugger supports any framework, even if you create your own one. And what you need to do to configure your own framework? Well, let's go to the config. And here you have a function that needs to return a list of lambdas with their source code. You just need to implement this. For input, you get functions that the Lambda Live Debugger found if you selected one framework. So you can filter by name, change source code. Maybe you have compiled JavaScript, but TypeScript is some special location, so you can modify that. You can modify how the bundle works, and you can provide your own list of functions, and that's all it takes to support your own framework. It's absolutely trivial. Yeah, that's about it about Lambda Live Debugger. I'm wondering if you have any questions.
So Marko, there are no questions at this point.
Okay.
Maybe you can continue. Yeah, thank you.
Cool. Now I will continue with the second part of presentation, showing you some tips and tricks regarding CloudWatch and logging. For that purpose, I created order processing system, which can accept orders and then process it. And this is typical service projects because everything is synchronous. Order go to API gateway, then event bridge, then SQS, and then to Lambda that process the orders. But let's imagine that you don't know anything about the project, but there are some alarms going on, and or users, customer complain that something is not working. How would you approach this problem? Well, first you would go to CloudWatch Log Insights. And there is a new feature here that you can query all log groups. And let's filter if there is any error. Yeah, just get some old from my practice. What I would see, there is an error with process order function. Okay, cool. And do I have any other info? Well, this doesn't help me much. Doesn't help me much, especially because, well, line numbers are for JavaScript and code is in TypeScript. So I need to enable mapping. But most important, it would be really nice if I would see what kind of messages are coming in. That's why I developed a simple tool, a Lambda layer that intercept calls and logging. And this is really useful when you have really environment and you just wondering what is the message that is coming in and causing all the problems. So you can read more about this layer here. And let's configure it. Pick the correct, you can read this on my blog. Pick the right ARN. That's it. And you also need to configure environment variable to basically enable the layer. That's it. Now I will open Logtails, which is another tool for from CloudWatch. I can see the logs coming in real time. So let's refresh. And here it is. What because I added that Lambda layer that add logs, I have all the incoming event and also what is coming out of the Lambda. So this is a really useful tool if you have a production system, don't know anything about it, and would like to check what's going on, what messages are coming in. But do remove this layer after use, because, well, logging is quite expensive and you don't need all that all the time, I assume. Okay, so here we have all the details, what's coming in, and if I would inspect this further, I would see that some data is missing, and that's why it's failing. So let's go to the code. Here is my process order function. And let's see what it's doing. Well, it receives events from SQS and go through process order, and each order has an item. And here's somewhere it fails. And first, I want to know which line it fails. So I need to enable code mapping. I go to CDK code and bundling. Source map. And I also need to add this environment variable in order to work. And of course, I need to debug, deploy. But let's go back to the code. How can we also improve this code? Well, what I would expect from logs, at least to tell me which order and which item in the order failed. Well, and let's add that. So I log which item, then also which order. Bear with me, I will get to the point soon. So in the logs, I will see which item and which order. But there's a problem with this. For one error, let's imagine that this is much more complex code. You could argue that you can pass the order ID to this function and log everything in one place, but not if the code would be more complex and have more layers. What is a better solution is to use the quite new JavaScript feature by changing errors. So new error, like before, and I can embed the original error. And again here, the same thing. So I'm not logging here, just rethrowing the same message, the same exception and adding some new information. And also here. And that's it. Let's try this. I will clear this log. Just wait a little bit. So let's retry. And yeah, here is my exception. It's only one. And I have chain of all the exceptions. And I can see the real code line number here because I turn on the mapping. And this is much more useful comparing to free logs that you need to figure out how they come together. Okay, but let's improve this. Once I figure out which order has a problem, I would like to get errors just for that order, not everything else. Certainly, I don't need all those logs. That's completely useless at this point to figure out what's going on. And that's structural logging. How this works. I log the whole JSON objects. Sorry. That's it. So with this, I can query by order ID. I will move now to another branch where I implemented this in multiple places. So I have structure log here, also on send order, and also when logging an error. But here I also attach an error, which I convert to a real object with this tool serialize error. Okay, let's deploy this. Clear this, and I can filter the only that order here. Another thing, LiveTales has an option to enable multiple to see logs in real time for multiple lambdas. So what we will see is passing an order through send order function, and then it goes through event bridge and SQS, and then eventually end in process order function, and all those parts will be logged. Like check, yeah, it's already deployed. refresh. Yeah, we have send. It's not completely in the right order, but I get a message for sending order to event bridge, processing order from SQS, and then our famous exception. Each time I see the whole object, everything, and I can query by this. And this way, it's really easy to debug complex event-driven system because you can see all the logs at the same place and also filter by some ID that you like, order ID or something, whatever you wish. Well, maybe you don't want to log everything because that's expensive. You can log just the basic things, but the important part is you can filter the data. And the same is for logs inside. Logs inside has also this capability, but the query language is a bit different. Here again, we have all three logs: send order, process order, and our exception. It's not best formatted. Well, it is okay. But it's really simple. Those tools are really efficient. A bit harder to use. The developer experience is not the best, but they are extremely powerful. And I didn't have to do much to take advantage of them. So you would say, oh, this logging, that looks like distributed tracing. Well, and AWS has a tool for that, X-Ray. First, what is distributed tracing? Well, what the name suggests, you trace the event, the message through all the system it passes. In our case, well, the system already figured out how our project is combined. You have a Lambda function that sends message to, you don't see that, to event bridge and SQS, and then you have another Lambda to process. The system could be much more complex, but just to get the gist of it. Now you can, let's see one of the traces. So here I have Lambda for sending orders, and I see how much time it takes for each part, and then the second Lambda for processing order. And here's another interesting thing. I can create my own segments if I want to inspect and time just part of the code. I will see how you do that, how you write that code, but what is important, this is my own segment. It takes a little less than a second to execute, and I can add my annotation. I can search by that annotation, and I can add metadata. So here is also an order which would help me to debug. And how do you search this? Here is another language that is different than others, but still quite useful. Did I mistype? Yeah, here is the trace that I found by filtering by order, because I set annotation for this order. Let's see what I have to do to configure this. First, I need to enable tracing on the Lambda. Then I need to change the code a little bit. Well, the important part is I need to add this. So messages that goes to event bridge, in this case, are also logged to X-ray. Then, as I mentioned, I can create my own segment and add notation and metadata to it. That's it. I must say I don't really like that X-ray very much because it's you need to add additional work to configure, and it's a bit tricky for some services, but it can be really useful. In most cases, that logging tricks that I mentioned does good enough job. Okay. There's another utility that I created that I would like to present. You can also find this on my blog. Oh, sorry, not the right one. Yeah. Usually when you configure Lambda, you add some alarms to it that are triggered when an error occurred. Alarm usually trigger SNS and send you an email. But the problem with this is you don't have any additional info. It could be just some simple timeout or really important issue. And what this construct does, it attached to that SNS. So when alarm is triggered, it queries CloudWatch and send all the logs for that particular function to your email. So you can see all the details, and if you did a proper logging and logged all the details, you can check that email and see what's going on. It's really the tool is useful if you use CDK, and that's the only thing you need to write. Nothing else. But even if you don't use CDK and you want to deploy to existing project, you can use this CloudFormation, deploy it, set which SNS should be monitored, well, attached to, and that's it. Really extremely simple utility. That's it. Since we have some time, I will show you another important thing. Let's go to one of those Lambdas. And here is one important thing. My logs are in the format of text. That's a default option, but now there's a new option to log as JSON. So you'll probably wonder, when I did structure logging, I always did this stringify. Well, if you enable JSON, you don't have to do this. And you can also configure which logs should be there. So you can disable all the system logs that you usually don't need. But the queries would be then a little bit different. So in live tail, it will be message like this. And in logs inside, it would be also first message, then order ID. So this is the only difference. And then you can also configure which level of logs you see in the logs, because in old text version you cannot disable different parts of the log. Yeah, that's about it. Welcome to read my blog. And please try Lambda Live Debugger. And that's it. Do you have any questions?
Hey, Marko. I am checking if there are any questions. But first of all, thank you so much for this session. I think more than a session, it was a small piece of a workshop where you walked us through how to configure see Lambda Live Debugger in action. And I mean, it was great to see how it works in action. So everybody, if you have any questions, please post it in the chat so we can get that answered. And I've also shared a link to the Serverless Live blog. Please follow Marko's blog. He writes some amazing content, and I'm sure you would not want to miss it. So Marko, one question from my side. You said that you are using a layer, right? And I'm sorry, I might have missed. So are you is the Lambda Live Debugger only configurable for JavaScript as of now, or any other runtime, sir?
No, just JavaScript and TypeScript.
Okay, JavaScript and TypeScript. Okay, understood. And in terms of layers, so you're adding a layer as needed, and your suggestion is to remove it once the local debugging is completed, right? Okay.
Yeah. Well, that's important if you have a project system that receives a lot of events. But if you just develop and when you don't develop, don't send any message, that's not really important.
Got it. Understood. So there are no questions. So Marko, I did share the latest blog that you showed, the CloudWatch alarms one. I think you referred to another blog before that. I missed that. So if you can, please share that in the link as well.
Just to find it. One is this. This is that CDK construct that you can use.
Right.
Now I don't know how to send a message.
Yeah, you can. There's a private chat here on screen.
Okay.
Yeah.
Yeah. Okay. Find it. and the other is adding that layer for extra debugging. That's the second one. And what I would also like to mention, I really like this block, how to lose your data with serverless without even knowing.
That seems interesting.
Yeah, and the most time I spent writing this block about DynamoDB single table, and it's a bit long.
Oh wow, I'm sure there's a lot of insights in it. I mean, single table design has always been not so easy. It's basically not everybody's cup of tea.
Yeah, because DynamoDB looks like simple. You go partition key, sort key. That's it. That's all the features. Then it's the whole science how to configure that. It's really surprising. Like, oh, do you know DynamoDB? Yes, say by the key.
Yes, yes. So yes, thank you so much, Marco, for joining us early in the morning. We really appreciate it, and we look forward. Thank you. I mean, it was for me personally, at least, it was a very insightful session. Took back a bunch of things with CloudWatch alarms and all those things as well. We thank you very much and look forward to hosting you again in the near future.
Yeah, thank you very much for inviting me.
Thank you so much.
Bye.
Thank you so much, Marco. Bye bye.
Okay, so everyone, as you all know, we were supposed to have Kishan as the next speaker, but unfortunately, due to some personal emergency, he is not able to join us today. And we have our savior Dharmendra here, who is going to take over his spot and and actually kind of continue from where Marco left with CloudWatch. So thank you, Dharmendra, for first of all stepping up when an unforeseen situation happened. And over to you.
Thank you so much, Susit. So, as Susit mentioned, because of some unfortunate family personal reasons, Kishan need to step back. So, in hurry, within some few hours, yesterday evening, we get to know about his situation. So, I just built something on the CloudWatch optimization for you guys, and let's see how it goes. So bear with me. It's just a theoretical part I'm explaining this time, but hopefully next in near future, I will be giving some demos to you guys, like how can we optimize the CloudWatch cost, and let's see, start with it. And yeah, so as you all know about CloudWatch in AWS, whenever you create any service which is associated with the CloudWatch, you might have debug it, or you might have seen it somewhere, and it's a service which always in the eyes of business teams as well, irrespective of what you are building. They doesn't care about sometime about your services like Lambda or any other service step function if you are using, but they always continuously check the CloudWatch matrices, like which service is performing how, and which is generating how much, which service is generating how much cost for their business, all those things. So let's start with it. So yeah, so you all know that CloudWatch is a powerful tool for your observability, and I personally believe like if you configure the CloudWatch properly and carefully, then you don't need any third-party tool uh, 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 for your observability. But for some different use cases, if you like the third-party tools, then obviously you can go for it. But within a cloud watch, if you configure them properly, your logs, your matrices, and there are other services, CloudWatch, Cost Explorer, all those things. We will be talking about them in the next slides. But if you use them properly, then I think CloudWatch is enough for your observability, for your application, and for your business team to look how your application is performing. And misconfiguration, obviously, yes. So any misconfiguration, or you forget about to configure anything with your services which you are using, and they are generating the CloudWatch logs, then it can be expensive for your application and your business as well. So we will see today, like, how can we reduce our CloudWatch cost from uh, up to 30% or even more if you do it properly. So first coming is log retention policy. So it is one of the most important uh, key term in the CloudWatch. When you are creating any log group or creating any service which is attached to a log group, then setting a log retention policy becomes a most important, or I can say it's a mandatory to set a log retention. And because take it as a, like, when you create an account, and if you don't set up your billing alarms, then it will give you surprise at the month end. If you building something, you will get surprised, like how much this bill came, and why I didn't get any notification. So uh, similar to that, the log retention policy is a also most important step when you are working with the CloudWatch logs. So it is highly recommended that you set a CloudWatch log retention for every log group which you are creating or getting created by default, like your Lambda logs or your step function logs, your MSK logs, any service which is attached to a log group. You have to be very careful when you are setting the log retention policy. You can divide it into based on your environment. Like if you are working in a prod environment, then you can increase your duration of that log retention. And if it is in your testing environment or in your local environment, it can be for less days. So based on your use case, you can always define the number of days. And if you are not setting your log retention, I think it's uh, never expire, I think, and it will always be there, which is going to be very expensive, and it will obviously generate the cost for you. And sometimes if you see the applications which is running on some services like Lambda, DynamoDB, so the cost of those services will be very less in compared to your CloudWatch. So most of the time CloudWatch is the highest cost generating service for your application. So you have to be very careful when you are uh, setting this log retention policy for your log groups. Yeah, so next, coming to manage high volume logs. This is one of the most important uh, topic for our this presentations, because when you are creating any service or you are logging any logs, so it becomes highly important you to log carefully what you are logging, how you are logging, how easily you can trace the issue in the future with the help of those logs which you are logging. So as and it always if you have seen in the CloudWatch logs, when you query your logs, if it is not in a proper structure, then it's very difficult for anyone to trace the logs. And we have to be logged such a way that if a person debugging your application first time, he or she also can debug it very easily. They should able to understand your logging easily. So we have to log in such a way. So yeah, so it always cost you when and how you are ingesting the data and how much quantity you are ingesting the data in your CloudWatch logs. It's always cheaper when you data which you are stored in the CloudWatch logs. But when you ingest the data and how frequently you are ingesting, the quantity of logs you are ingesting, that will be always expensive, and the pulling of data from the CloudWatch logs. So these two things will be very expensive when you are working with the CloudWatch logs. I think it's a limit of 1 MB or something when you insert cloud logs in your CloudWatch. And yeah, suppress debug trace logs in production. Yeah, so when it comes to the high volume logs, like if we everyone knows that when we are working with the applications, the entry point of your application, so most of the time we always log it. It can be a very large payload sometimes, or a payload sometimes which you are extracting from DynamoDB some data, or passing some data to the third party tool, and you want to log it for some reasons. So you can always suppress it, and highly recommended to compress it when you are logging it in a production environment. For your local environment or your lower environment, like testing environment, you can you may compress or not, but in production you should compress it so that it uh, don't generate too much cost for you. And next is use matrix streams for efficiency. So yeah, so when you are integrating the third party tool with your CloudWatch logs, so what happens, they pull the data from your application, and then they will show it in their dashboard. So this is one of the important point where you are deciding when they are going to pull your data from your application. So let's say you are logging some logs in your CloudWatch, and after there is a time period when they pull the log once in a day or twice in a day based on the requirement of your application. So instead of that, what you can do is you can log the data when you are sorry, you can uh, pass the data when they are logging the data actually. So because at that particular time you are already the environment is already there, so you are logging your logs as well as passing the logs to the third party tools. So that will be little cheaper in comparison to they pull the data based on their time. And yeah, and uh, for this high volume logs we have some tips like batch matrix data. So whenever you are inserting data in the CloudWatch logs, always try to insert in batch, which will obviously help you to reduce some cost. And as we discussed, the get metric data, when you are pulling data from your CloudWatch log, try to reduce the frequency of pulling those data from third party tools. Coming next to the minimize vended and detail monitoring logs. So what is this minimize vended and detail monitoring logs? So basically you guys have noticed that there are some default matrices provided by the CloudWatch logs, and if you go to the matrices, you can see the resolution time like 1 minute of some matrices and 5 minutes of some matrices. So when we are working with the matrices, there are two types of monitoring provided by the CloudWatch and AWS. So first one is basic monitoring, which comes with the resolution of 5 minutes. So which means for a 5-minute time of interval, you can see what how many entry points are there. So let's say if your Lambda is generating, your Lambda is getting feeds continuously, and and when you go to the monitoring matrices for that particular Lambda, so you can see over there for 1 hour how much entry points are there, invocations we can say, and then you can resolve it to 5 minutes. So with the basic monitoring, they support 5-minute resolution. So in 5 minutes, how many invocations you are getting? So that is comes with the basic monitoring. Detail monitoring is little bit expensive in comparison to basic monitoring, obviously because it gives you resolution time of 1 minute. So you can drill down till the 1 minute, like in 1 minute how many invocations your application is receiving. So all those things you can do with the detail monitoring. And some of the services like Kafka, you can do that detail monitoring. I think API gateway and many other services also support detail monitoring. So you can drill down to a specific part of that particular service. Like if we see in Kafka, there are broker, like per broker how many invocations are there for 1 minute, like some of those invocations, all those things you can do with the detail monitoring. Going to the next, efficient use of matrix filter. Yes, so when we are working with the matrices in the CloudWatch logs, so it becomes very important when you are creating those matrices. Like I think there are some limit of free matrices, like up to 3 or 5 we can create, and AWS providers basically. And up to after that, whatever matrices you are going to create, they will be uh, charging to you per matrices. And yeah, so when we are creating the matrices, we have to be carefully creating them, like we have to consolidate them based on the group of errors which you want to show. Let's say you want to show some specific error, like 200, like successful messages 200. So if you group them by that 200 code, then you can easily figure it out, like how many success invocations your application have done. And similarly you can do uh, uh, for errors also, like if it is a 400 error, or it is a 500 error, 501, 503, all those kinds of errors you can group and add it in your filter. And avoid filters on high frequency logs unless necessary. So yeah, so when you are uh, creating the filters, so you have to be very uh, skeptical when you are using the high frequency logs. So uh, because if you are creating the matrices for any high frequency log, so which means your matrix will be very expensive uh, in terms of logging, because continuously logs are coming, and at the same time your matrix is also getting the data points, and they keep the trace of that data point in the matrices. And when you are going to that matrix and uh, for a particular time window, if you are looking, or let's say 1 week time window, or 5 days, then it will scan all those logs for your that matrices, and it will show to you. So you have to be very you need to avoid, actually, when you are logging the you are creating the filters for your high frequency logs. So that is one of the uh, recommendation for using matrix filters. Okay, now coming to our login sites. So most of you are already aware about login sites, and in our previous talk, Marco also mentioned few of the strategies which we can use in our login site. Like we can build our logs in such a way that we can easily trace the logs, like following a proper structure. If we take example of Marco, like he had a order ID, and that order ID is passed to the each step, and then with that order ID he can trace basically his entire process of that particular order. So similarly, whenever you are logging uh, any survey logging in your CloudWatch, for each step, it becomes very important, and how easily you can trace it, and how fast you can trace it. So that is where these login sites help us. And if we come to the cost of this login site, so it always costs us per GB of data which we are scanning. And like when we scan in a CloudWatch log matrices, sorry, when we scan the CloudWatch logs inside, uh, it is recommended to use always the narrow time range. Let's say if you want to debug a issue which happened yesterday, so and you know exactly time when it happened, so you can use that particular time of like let's say 1 hour, and then debug the logs of that particular 1 hour. So you are not scanning the logs for the entire day, you are just scanning the logs for the particular day, which will be helpful when it generate the cost of your data scan. And as we discussed in the first slide, where we were discussed like about uh, log retention policy. So let's say you have set log retention to 7 days, and in production you have 14 days. But and if you want to log or want to see the logs of uh, old date, like more than 14 days previous logs if you want to see, but you have log retention of 14 days. So how can you see that? So for that we can alternatively store our logs in the S3, and with the help of kinesis, I think you can use and store the logs in the S3, and later from S3 you can query them through Athena. So Athena is again a great tool for querying our logs, and uh, uh, giving us exactly the same amount, same behavior which we uh, get from CloudWatch logs. So you can uh, create tables, uh, you can query your logs in the Athena more than your retention period time, and you can store logs. Also, you can set a date in the S3 also, like you want to store logs for 2 months, 3 months. So there also you don't want to store it for uh, long lasting, but you want to store them for minimal days, so that it also don't generate uh, your cost too much. Yeah, so next thing is visualizing your cost with the cost explorer and user report. So most of you have seen the graphs for your CloudWatch matrices in most of the presentation. So that is comes from the cost explorer, which gives you the uh, 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 like bar diagram for your each service, like how much it is generating the cost. Also it predicts like how much cost it will be for that particular service in the upcoming month or this month. So that is a very useful feature of cost explorer, and most of the time business teams use all those cost explorer services. And users report is like a sheet which gives you descriptions of each and every service, like how much that particular service is charging you for this particular month. And when you are working with the cost explorer, you have to be tagging your services so that you can properly check them in the cost explorer, and you will see there multiple color of diagram. So each you can set the color for each service and tag for each service, and then in your cost explorer you can easily check like how much your that particular service is charging you. And it can help you to identify which application is costing you high and which is costing you low, so that you can focus on the high cost generating applications, and you can reduce the cost based on your uh, uh, logs and all. So this is what we can do with cost explorer. And user report coming next to. Yeah, so we have almost 8 slides we have covered. So coming to the conclusion and the next step which you can follow. So far we have seen like many practices which we can do with the CloudWatch, like setting up the retention, filtering the matrices based on the volume of logs. If it is high frequency log, then avoid setting matrices for those logs, and prioritize your CloudWatch logs based on the non-prod and prod environment. You have to be regularly reviewing your matrices, auditing your reports, regularly checking the cost explorer, and with the help of all those things, you can see your usage pattern of the CloudWatch logs, where you will see, as we discussed earlier, like which service is generating how much logs, so that in with the discussion of your team, you can reduce the cost of those services and log such a way that it benefit your application. And you can use AWS tool for this, like cost explorer, and you can create your own matrices and audit reports, which can help you with the with the optimization of all these CloudWatch logs. And I'm sure that with the help of all those all the points we discussed earlier, it will definitely help you to reduce some cost in your CloudWatch logs, and also help the application running smoothly and debugging. And you can easily debug your application with all the steps which we have discussed in our all these slides. And I think, yeah, that's it for the today presentation. Uh, it was prepared in just 2 hours and just a theory, but thank you so much for being here with us today.
Okay, perfect. Thank you so much, Dharmendra, for your insights on CloudWatch costs, and more importantly, stepping up in the situation. I mean, as you rightly pointed out, I think CloudWatch, one, is a very underrated service. Like you started your talk by talking about how it can potentially replace any other third-party services or tools, right? Of course, there are a lot available, and they do have their own edge. But CloudWatch is decent, and it is good enough if you know what to do and how to do it and how to leverage it, right? And CloudWatch, as Marko also mentioned a couple of times, is one of the services that's relatively costlier. So you have to be careful about managing your CloudWatch costs. And this session, which Dharmendra just covered, has many insights on how you can do it. Um, I mean, one of the things that I did was, by default, the CloudWatch log groups get created with a never expire time limit, right? So I have had log groups that date back to 5 6 years, which I never use. I never look at it, but still it happens, right? So make sure after the session you go back and check your log groups to see if you really need such long retention periods. If not, push it to S3 after a period of time, and then you can query it. You can keep it for 5 6 months depending on your policies, retention policy of your company, for various audit reasons, right? And we can certainly do that. So go back, check it out. CloudWatch is one of those things which of course will not add value to your feature per se, but will of course help you a lot in debugging and slowly eat into your CloudWatch builds. So take care of that. And thank you so much, everyone, once again for joining us today. We know it's a Saturday. You've all been patient and joining us. So thank you so much. And before I leave, I quickly wanted to share something interesting with all of you. And so I thought it is something that would excite you. I hope my screen is visible. So, for people who are joining us from the APAC region and Japan, there is a Amazon Q challenge that is or campaign that is going on right now. It is till 20th of next month, if I am not wrong. Yeah, 20th of June. So what you'll have to do is you have to simply build a game using the Amazon QCLI. It is very easy, simple, and very intuitive. I have seen a lot of people build all the retro games. I've even seen someone build a Mario game using QCLI. So if you have something really interesting idea to build a game, you wanted to build one, and today you have an option to leverage QCLI and do that. And the best part is you also stand a chance to win a T-shirt. So you will have to submit your details, and you have to write a blog about it. And if it is authentic and it's not plagiarized, obviously, then you stand a chance to win a Q T-shirt. So I am gonna share this link in the chat for you guys to take a look at it. It is very interesting. I mean, keeping aside the lucrative part of having a free T-shirt, it is important, and I mean, to you can get a hands-on experience with QCLI. So yeah, that's pretty much it from our side. We will be back again next month with a couple of other interesting sessions. In the meantime, if any of you are interested in presenting, do reach out to us. We are available on LinkedIn, X. You can easily reach out to us. So thank you so much once again, and have a happy weekend.
Yeah, just to add on this game, like I also tried to build with the Amazon QCLI last week. So I shared it in the chat. Just try it out and see how it working. And if you like that game, just ping me, LinkedIn or anywhere. And thank you so much for joining us today. And yeah, see you soon in the next Serverless Saturday meetup again.
Thank you. Bye bye.
Thank you. Bye bye.